Moving on, other problems that popped up interpreting the universe under a secular interpretation, one of which is rotation curves. We can measure the velocity of stars as they orbit the centers of their galaxies, and physics makes certain predictions about how fast they should be going depending on how far they are away from the center. It turns out that the ones at the edges of galaxies, for the most part, are moving too quickly. Now, there's several explanations for this. The most popular one by far today among secular cosmologists is called dark matter. It turns out that you can explain these speeds if there was a big halo of mass outside here. That changes the way the dynamics work and changes the velocities. So therefore, there must be actually a lot of stuff out here that's doing that. Well, what is that stuff? It's dark matter. We don't see anything there. Well, that's because it's invisible. What do you mean invisible? We don't know of any matter that would do that. Actually, I should qualify that statement. There are solutions to this that are available, but the secular community rejects them, and I'll talk about this later. For now, dark matter is by far among secular cosmologists the predominant view that there must be all this extra stuff to explain these particular issues, even though we don't see anything. Now, they have subsequently discovered that some of the conventional solutions they thought they had for what dark matter might be don't work. So now the search is onward for exotic new forms of matter that don't produce light. I mean, they don't produce radiation of any kind. No X-rays, no light, no radio waves, whatever. The only effect it has with everything else is gravity. However, particle physics doesn't have anything like this. And even some secular cosmologists are uncomfortable here. This guy said, it's an embarrassment that the dominant forms of matter in the universe are hypothetical. So when you look in the sky, you see stars, planets, galaxies. That's normal matter. Cosmologists are now believing that there's a lot more dark matter than there is normal matter. And dark matter, again, is this hypothetical new form of matter that we don't know of. Moving onward from there. In the late 90s, it was discovered that some very far objects are displaying redshifts that are not consistent with Big Bang predictions. When interpreted under the Big Bang model, it appears that the universe's expansion is accelerating. Well, what could be doing that? Well, that's called dark energy. As Astronomy Magazine explained, to get enough oomph, that's a technical cosmological term, to drive the present acceleration of the universe, dark energy must make up about 73% of the total density of the universe. Now, basically, dark energy is anti-gravity. It's pushing against the gravitational attraction that all these various objects would otherwise have for each other and accelerating the expansion of the universe. But the biggest problem with this idea is that no one has any idea what dark energy is. So far, all we've been able to do is to name it. The nature of the dark energy that's causing the expansion of the universe to accelerate is now perhaps the most profound mystery in cosmology and astrophysics, and it may remain forever so. So let's take a brief state of the universe status. Here's what present cosmology tells us is true. 4% of the universe is normal matter, planets, stars, galaxies. It's everything we see in space. Almost a quarter of the universe is dark matter, which is completely unknown to physics. 3/4 of the universe's mass energy is dark energy, this mysterious anti-gravity that's, again, completely unknown to physics. Now, the Big Bang model is supposed to explain everything. It's the theory of the origin of the universe, right? Now, if your theory of everything only explains 4% of everything, do you really have a theory of everything? I would say no. Yet it's still presented to us as a successful model.